Have you ever wondered what gives life to the technology all around us? Look closer. Deep inside every phone, laptop, and even the spacecraft exploring our solar system lies a marvel of engineering. The central processing unit. It's the brain of the digital world, a tiny powerhouse that executes billions of commands every second. What houses incredible piece of technology, man? Our story begins not in a high-tech lab, but with something far more common. Sand. It all starts with quartz sand, which is refined until it becomes silicon that is 99.9999999% pure. This ultra-pure molten silicon is the raw material for our digital brains. Using a method called the Czochralski process, a tiny seed crystal is dipped into the molten pool. As it's slowly pulled upwards and rotated, it grows into a massive single-crystal cylinder called an ingot. This perfect crystalline structure is essential for the microscopic circuitry to come. Once formed, these ingots are sliced with incredible precision by diamond-edged saws into ultra-thin discs known as wafers. Each wafer, now polished to a flawless mirror finish, will become the canvas for hundreds of individual CPU chips. This delicate work takes place in a clean room, an environment thousands of times cleaner than an operating room. Here, technicians in full-body suits handle the wafers with extreme care, as even a single speck of dust could ruin an entire batch of chips. The stage is now set for the most critical and complex step in the process, photolithography. This is where the magic truly happens. First, the wafer is coated with a light-sensitive material called then. A beam of ultraviolet light is projected through a mask, which acts like a stencil, holding the intricate blueprint of the CPU's circuitry. This light etches a pattern onto the photoresist, creating the foundational layout for billions of transistors. These microscopic pathways are so small that they are many times smaller than a virus. It's a process of drawing with lights on a scale almost too small to imagine, laying the groundwork for the chip's intelligence. Next, we need to give these transistors their switching ability. This is done through a process called doping, where beams of ions are precisely fired into the silicon by embedding different atoms into the silicon crystal. Engineers create N-type and P-type regions. These regions alter how the silicon conducts or blocks electricity, forming the fundamental on-off switches that are the basis of all digital logic. Following doping, chemical etching processes are used to wash away the exposed photoresist and unwanted silicon, revealing the intricate transistor structures that were just patterned. A modern CPU isn't a single flat circuit. It's a skyscraper of electronics. Using techniques like vapor deposition and plasma, dozens of layers of insulating material and conductive metal are built up on top of each other. Tiny copper wires, thinner than a human hair, are meticulously laid down to form an incredibly complete three-dimensional network. These are the interconnects, the superhighways that link the billions of transistors together, allowing them to communicate and work in unison. A single CPU. You can have over 50 of these layers, all stacked with perfect alignment. Once the skyscraper of circuitry is complete on the wafer, it's time to separate the individual chips. The wafer is precisely diced into hundreds of rectangular dies, each one a potential CPU. These dies then undergo a rigorous testing phase. Robotic arms place probes on each chip, running a battery of tests to check for any defects and measure their performance. Only the highest performing, flawless chips will make it into high-end computers. Chips with minor imperfections might be repurposed for less demanding devices. Finally, the successful dies are packaged in a protective ceramic or metal enclosure with pins to connect them to a motherboard ready for installation. So, what's actually happening inside this tiny package? A CPU has several key components. The control unit, which directs operations. The arithmetic logic unit, or ALU, which performs calculations. And registers and cache, which provide ultra-fast temporary storage. Everything the CPU does follows a cycle. Fetch, decode, execute, and write back. It fetches an instruction from memory, decodes what it means, executes the command, and writes the result back to memory. This entire cycle happens in mere nanoseconds, billions of times per second, allowing your computer to run complex software seamlessly. The evolution of CPUs is relentless. Today's processors feature multiple cores, allowing them to handle many tasks at once. They include specialized hardware like AI accelerators to speed up machine learning, and engineers are even stacking chips vertically in 3D configurations for more power in a smaller space. We're now manufacturing transistors at the 5 nanometer scale, with industry giants like Intel, AMD, and Apple constantly pushing the boundaries of physics. Modern CPUs contain tens of billions of transistors, each smaller than a single red blood cell, all working together with incredible speed and efficiency. From a simple grain of sand to the intricate thinking brain of our digital world, the journey of the CPU is a testament to human ingenuity and our relentless pursuit of progress. It powers our cities, our communication, our creativity, and our exploration of the universe. The CPU is one of humanity's most advanced and impactful creations. Small in size, but truly infinite in its power. Thanks for watching. If you found this journey fascinating, don't forget to like, subscribe, and follow for more deep dives into the technology that shapes our world.